right now, at this very moment, in the empty space between this screen you're looking at and your eyes, in what appears to be silent, dark nothingness, billions of particles are popping in and out of existence, trillions of times per second. This emptiness isn't empty at all. Actually, quite the opposite. It's one of the most active, most insane places in the universe. And this reality is going to challenge everything you think you know about existence. You've probably never really thought about it. When you hear the word void, what comes to mind? Nothing. Silence. Darkness. Death. We've been thinking this way for thousands of years. The ancient Greeks called emptiness kenosis, literally nothingness. Aristotle said nature abhors a vacuum, horror vacui, the fear of emptiness. Because to him, true void couldn't exist. Boy, was he wrong. Empty space, we figured, was literally empty, nothing there. But this approach is maybe one of humanity's biggest conceptual screw-ups, because nothingness doesn't exist. Never has. Never will. This claim sounds nuts, I know. It goes against your gut instinct. But science has been proving our intuitions wrong for centuries. Earth looks flat, but it's round. The sun seems to go around us, but we're orbiting it. And emptiness looks empty, but it's actually one of the richest, most complex places in the universe. Put your hand up in the air. Now look at the space between your fingers. That space looks like it's got nothing in it. But in reality, there's an invisible ocean churning around. Quantum waves going up and down. Virtual particles dancing around. And here, in this seemingly innocent void, lies one of the universe's deepest secrets. Close your eyes now and picture this. From the ocean's surface, water looks calm and smooth. But dive in, look through a microscope. Billions of molecules going crazy. Water's never truly calm. Just like that, space is the same way. Calm on the surface, totally wild in the depths. Back in the early 1900s, physicists discovered something weird. Even at absolute zero temperature, the coldest possible condition in the universe, minus 459 degrees Fahrenheit, atoms were still moving around, not stopping, vibrating. This seemed impossible. If temperature means motion, then at absolute zero, motion should stop. But it didn't. We called this zero-point energy. Like the universe itself had some kind of lower limit, a threshold where stillness becomes impossible. Atoms, even in the coldest spots in the universe, can't stop dancing, because the laws of quantum mechanics don't tell them to stop. They say move, keep moving, always. But the really mind-blowing thing was what was happening in empty space itself. Werner Heisenberg told us this. At any point in the universe, we can't know energy and time with perfect precision at the same time. This isn't just a problem with our measuring tools. This is how physical reality actually works, how nature operates. Think about this. Heisenberg saying nature is uncertain. There are no definite values. Everything lives in probabilities. This sounds insane, because in our daily lives, everything seems rock solid. Your desk's right there, your car's over here, the sun rises, sets, everything's predictable. But in the quantum world, nothing's certain. An electron can exist in multiple places at once. A photon can be both wave and particle. And the craziest part, empty space itself is uncertain. That void constantly borrows energy, pays it back. The universe itself operates like it's got a credit card. Now combine this uncertainty principle with Einstein's famous EMC quadride formula. What do you get? An incredible result. Particles can literally be created out of thin air. Energy and matter can transform into each other. And empty space itself goes through constant energy fluctuations. These fluctuations are so powerful, they can create electron-positron pairs for just an instant. Antimatter particles. One electron and its opposite, the positron. Both real, both measurable, and both wipe each other out very shortly after. These virtual particles live only 1/trillionth of a second, then destroy each other. But during that brief moment, they're completely real, measurable. They can interact. They produce real concrete results. Like the universe is constantly playing poker with itself, dealing cards, collecting them back, dealing, collecting. In 1948, this Dutch physicist named Hendrik Casimir made a mind-blowing theoretical calculation. What happens if you put two metal plates really close to each other? Casimir figured out that quantum fluctuations in the void between the plates would have different density than those outside, because only certain wavelengths of fluctuations could squeeze into that narrow gap. This created a different vacuum pressure than outside the plates. Sounds crazy, right? The nothingness between two metal pieces is pushing them together. Casimir's calculations showed that quantum fluctuations between the plates carried less energy than those outside. This energy difference would create a force pushing the plates toward each other. Did people buy into Casimir's idea? Nope, it seemed way too weird. How could empty space push on anything? But in 1958,
They actually did the experiment. They took two super smooth, super close metal plates, leaving only a few atomic widths between them. And what happened? The plates got pushed toward each other, exactly like Casimir predicted. An invisible force was coming from what appeared to be completely empty space. This experiment was done, measured, verified, done again. Same result every single time. This was the first solid experimental proof that nothingness doesn't exist. Even empty space had a measurable effect. This thing we call the Casimir effect now affects nanotechnology, a real force we got to account for when designing tiny machines. The power of nothingness. John Wheeler, one of the 20th century's greatest theoretical physicists, made an even more mind-bending prediction. At the tiniest scales, what's called the Planck length, 10 to the minus 35 meters, space-time itself must be foamy. At this scale, the uncertainty principle is so powerful that space-time's smooth structure breaks down. This scale is hard to wrap your head around. How small is Planck length? A proton is 10,000 times bigger than an atomic nucleus. An atom is 10 to the 25th power times bigger than a Planck length. So an atom, compared to you, is way bigger than you are compared to a galaxy. We're talking about that tiniest scale.
At this scale, space-time isn't a smooth stage anymore. Tiny wormholes open and close, virtual black holes pop up and vanish. Space-time itself churns like a foaming ocean. Wheeler called this quantum foam. Here's how to picture it. From the ocean's surface, water looks smooth, but check out the molecules, and you see they're in constant motion. H2O molecules dancing, smashing into each other, separating, getting back together. Space-time's the same way. At big scales, it looks smooth, following Einstein's relativity. But at the tiniest scale, it's going absolutely nuts. And this activity isn't empty. This is the universe's basic structure, the foundation of matter, energy, even our existence. Right now, as you're reading these words, these quantum fluctuations are happening in every cell of your body, every atom, every proton, every electron swimming in this invisible ocean, surfing the waves of quantum foam. In 1998, astronomers made a shocking discovery. They were studying supernovas, exploding stars, using these explosions to measure how fast the universe is expanding. Their expectation was simple. The universe is expanding, but gravity should slow this expansion down. But the measurements showed something surprising. The universe's expansion wasn't slowing down, it was speeding up, like some invisible force was pushing galaxies away from each other. This seemed impossible. Gravity's an attractive force. It should pull everything together. So who was pushing the galaxies apart? We called this force dark energy. Dark because we can't see it, can't touch it. Energy because it's moving stuff around. And this force makes up 68% of the universe. Most of the universe is made of something we've never seen, never understood. Where's dark energy? Everywhere. In the empty space around you. In every cubic inch you can't see or touch. Right now between your fingers, in your lungs, everywhere. And it's constantly working, stretching the fabric of the universe. This isn't just proof that nothingness isn't empty. This is proof that nothingness is an active force shaping the universe's future. Billions of years from now, dark energy will push galaxies so far apart that future astronomers will only see their own galaxies. The rest of the universe will become invisible. Nothingness is writing the universe's story. Now stop for a second and think about this. There's really ancient light coming from every corner of our universe. 13.8 billion years ago, just 380,000 years after the Big Bang, the first photons were released. The cosmic microwave background radiation. This radiation fills empty space. Right now, billions of photons are passing through your body every second. The echo of the universe's first moments. The guys who discovered this light, Arno Penzias and Robert Wilson, were working at Bell Labs in 1965. They were using this massive antenna and kept getting this annoying noise. They figured it was electrical problems. They thought maybe pigeon crap inside the antenna. They cleaned it out, but the noise kept going. Turns out they were listening to the universe's voice, the echo of the Big Bang. That noise was the universe's birth scream, and it's still there today. In old TV sets, when you couldn't find a channel and saw static on the screen, a few % of those static dots came from the universe's first light. But this radiation isn't perfect. There are tiny fluctuations, small temperature differences from region to region. This is huge because if a perfect universe were possible, nothing would exist. No galaxies, no stars, no you. And where do these fluctuations come from? Quantum uncertainties. In the universe's first moments, quantum fluctuations expanded to massive scales. Those tiny quantum vibrations determined the universe's structure. Galaxies, stars, planets, even you, are descendants of those first quantum fluctuations. Nothingness built the universe's blueprint. This means you're not some accident. You're an inevitable result of the quantum vacuum. Nothingness worked for billions of years to create you.
Every atom in your body was once created in a star's core. These atoms came together through processes controlled by quantum fluctuations. You are, literally, a product of the quantum vacuum. Think about this. The calcium in your hand was created through nuclear fusion in a star's core. The iron in your blood was made in a supernova, at a star's moment of death. The carbon in your body will be the basic building block for future generations of life. You're a cosmic recycling project. But there's something deeper going on. Every neuron in your brain operates through constant quantum interactions. Your thoughts are a reflection of quantum processes. Your consciousness is a complex dance born from vacuum fluctuations. You're the universe's attempt to understand itself. The quantum vacuum's way of checking out the activity within itself. And this isn't just some poetic metaphor. Actually, ion channels in your nerve cells use quantum tunneling. Microtubules in brain tissue show quantum coherence. Maybe consciousness is the quantum vacuum's way of understanding itself. Modern cosmology suggests our universe itself might be one giant quantum fluctuation. Out of nothing, from the quantum vacuum, an energy explosion, the Big Bang. But this is just the beginning. According to this theory, our universe is just one of infinite universes born from quantum vacuum. Right now, other versions of you might be living in other universes. According to quantum mechanics' many worlds interpretation, every measurement, every decision splits our universe in two. Infinite parallel universes, infinite versions of you, and all born from quantum vacuum fluctuations. Is this terrifying or awesome? Maybe both. Nothingness creates not just one universe but infinite universes. This entire multiverse emerges from the activity within the vacuum. The ancient Greek philosopher Parmenides said, "Nothing comes from nothing. Ex nihilo nihil fit." For thousands of years this seemed logical, made sense. Aristotle said the same thing. All of classical physics was built on this foundation, but quantum mechanics shows us Parmenides was wrong. Everything can come from nothing, or more precisely, from the quantum vacuum, and it constantly does. Every moment, everywhere, even right now, in this room between your fingers, within your thoughts. Science has blown past philosophy, or maybe redefined philosophy. It has totally changed our concepts of existence and non-existence. Nothingness isn't some passive state. Nothingness is a dynamic field full of potential, the main source of existence.
Time itself is connected to quantum vacuum fluctuations. At the smallest scales, time itself is uncertain, fluctuating. Below Planck time, -10 to the -43 seconds. The concept of time loses meaning. What's this mean? Time is a rhythm living within nothingness, not some fixed, unchanging flow. A dynamic process pulsing with the vacuum's heartbeat. Quantum vacuum research could totally revolutionize our technology. Tiny machines generating energy from the Casimir effect. Vacuum fluctuations enabling quantum computing. Even Alcubierre drives for space travel, bending space-time to travel faster than light. And here at the end of this discovery we understand this. Nothingness doesn't exist. Every corner of the universe is packed with energy and activity. Even the emptiest-looking places are buzzing with complex quantum processes. This truth teaches us some serious humility. How wrong our gut instincts can be. It shows us the universe is way richer, more complex, more alive than we thought. Every place we call empty is actually the source of existence. Right now, as you're reading these words, an invisible symphony is playing around you. Quantum fields dancing, virtual particles popping in and out of existence, dark energy stretching space-time, and you're standing right in the middle of all this cosmic activity. In the emptiness around our pale blue dot, our Earth, billions of hidden stories are unfolding. Dances of quantum particles, brief romances of virtual pairs, wild turbulence of space-time, the silent push of the Casimir effect, the invisible expansion of dark energy. And you're not just watching these stories, you're part of these stories. The main character, you're children of the quantum vacuum, conscious beings created by nothingness to understand itself, the universe's way of discovering its own richness. Consider this. 13.8 billion years ago, this universe born from quantum vacuum became complex enough for you to understand these words today. Atoms were created in stars, planets formed, life emerged, consciousness developed, vacuum fluctuations understood themselves. Maybe this is the universe's most incredible secret. Nothingness created beings who could question, understand and appreciate its own existence. We're the vacuum's eyes looking at itself. Nothingness's tool for discovering its own richness. The quantum field's way of watching their own dance. The cosmos works like this. Everything's connected to everything. From the tiniest quantum fluctuation to the biggest galaxy cluster. From the infinite activity within nothingness to your ability to understand these words right now. From Planck scale foam to cosmic microwave background radiation, all one. And the final sentence is this: nothingness is impossible, never was, never will be, because nothingness is everything. Void is fullness, silence is symphony.
Non-existence is existence. This is the universe's greatest paradox and most beautiful truth. Nothing comes from nothing, and nothing isn't nothing.